Hello everyone, a very warm welcome to another virtual session of Science Children. So today what are we going to have? I hope you all have done the journal work for the acid, bases and salts, the experiment which we have done in the previous session, and the instruction was given clearly to you all, and you have to complete your journal. Your journal work has to be done. All the writing part was discussed and the diagram was also discussed with you all. So in today's session for this experiment 5 acids and bases, where you have learned the test to identify acid and the base with the help of red and blue litmus paper or red and blue litmus solution. So this was the experiment based to identify the nature of the substance, whether acidic or basic or neutral, with the help of the litmus paper or litmus solution. So in this session you will have a video on how this experiment can be done in the lab, and you will see the virtual lab. You will come to know how actually this experiment is done. So please do watch video, children, and go through the video and see practically how you do this experiment in the lab. Thank you, children. Please do watch the video and have a wonderful day.
Mr. Archer's experiments. Okay, Mr. Archer, it's time to do an experiment. Are you ready? No, you're not. Why? Yes, that's right. You've forgotten to wear your lab glasses. Great. Are you ready now? No, you're not. You've forgotten to wear your lab coat. Come on, get it on now. Right, and don't forget to wash your hands. And if you're dealing with any strong chemicals, just make sure that you are wearing gloves too. Okay? Are you ready now? Yes, you are! Great! Let's go! In front of you, you can see the 2 spot plates, and we're just about to set up the experiment by first putting some of the red litmus paper on the top row. And to do this, we're using our forceps because we don't want to touch the paper and get the chemicals on our hand, or get all the skanky, horrible, rubbish junk like bogies and poo that you have on your fingers onto the paper, because that would contaminate it. Right, of course that's true. There was a little bit of trouble doing it with the blue one, so it took longer, but thanks to movie magic I just cut it out. But we just want a small amount in each, and then onto the paper we are going to drip a drop or 2 of each of the substances that you can see. Well, that's that. So let's take the hydrochloric acid, and we'll use the dropper, dilute hydrochloric acid I might say, and we'll use the dropper to drop it onto the red litmus paper first. In this case it's not so apparent from the video, but we do not touch the paper with the drop still attached to the dropper. And you can see that it turns the blue litmus paper red. So on with the second one. Ethanoic acid, more commonly known as vinegar. Drop it on the red one, drop it on the blue one, and it changes the blue one red. Next, sodium hydroxide, another dilute solution. This time we know it's an alkali, so when we drop it on the red litmus, it changes the red litmus blue, and it changes the blue litmus, no, it doesn't change. It remains blue. Next we take ammonia, which is another alkaline solution, and we drop 1 drop onto the red litmus and it changes blue, and 1 drop onto the blue litmus and it doesn't change. Finally, the distilled water. Well, this one is just in this bottle, so we can squirt it out quite easily. And it doesn't change anything. Let's summarize the litmus paper experiment that we just did. Here is a table which shows the color changes. You can see that in the red litmus paper row, the hydrochloric acid, the ethanoic acid, both remain red. But when we put those acids on the blue litmus paper, they change color from blue to red. Conversely, when we put sodium hydroxide or ammonia on the red litmus paper, they become blue. And when we put them on the blue litmus paper, they remain blue. The last one is also very interesting for us because although it does absolutely nothing, the red litmus paper remains red and the blue litmus paper remains blue. You can see from the table, if you look at that top row, why we cannot assume that if we put something on red litmus paper, we cannot assume if it remains red that it is an acid. Because, yes, it could be an acid, like hydrochloric acid or ethanoic acid, but look at that last column. It could also be distilled water. That's really lovely highlighting, isn't it? And the same is true for blue litmus paper as well. So I've just summarized, though, what I've been saying here in a few sentences. And one of the key points I'd like to make is this last point, that to know if a substance is acidic, neutral, or alkaline, we need one and sometimes two tests. We need one test if the red litmus paper becomes blue or the blue litmus paper becomes red. And in all of the situations, we need two tests.